Life After Whale, The Amazing Ecosystem of a Whale Fall by Lynn Brunelle. Illustrations by Jason Chin. She drifts slowly. The late afternoon sunlight slants through the rippled water overhead and streams down the skin on her back. Just above her, thousands of tiny shrimp-like krill merge and mingle into a massive pink cloud near the surface. With a single beat of her enormous tail fluke, she surges up and lunges. Her jaws close, trapping countless krill in her mouth, while her elephant-sized tongue shoves around 21,000 gallons of seawater out through the baleen, a kind of filter attached to her upper jaw. The baleen is thin enough to let the water flow through and thick enough to capture the tiny crustaceans. One hefty gulp, and she swallows enough krill to fill a school bus. She's a blue whale, the largest animal ever seen on Earth. This beautiful creature measures over 81 feet long and would be more than 8 stories tall if she walked on land. She would dwarf any dinosaur, and yet she moves with grace and power like a dancer as she plunges, drifts, and whirls above and below the currents of the Pacific Ocean. Her years are told in her ears. Every 6 months, a new layer of wax lines her ear canal. In summer, when there is much to eat, the layer is light-colored, and in winter, when there is less food, the color is darker. Like rings in a tree trunk, these layers tell her age. 180 rings line each of her ears. The rings can tell so much more. Chemical stories that whisper about the history of the oceans, the temperatures of the water, or the pollution in the sea. They can show how many times she was pregnant, whether or not the feeding was good in a certain summer, or if the travel each spring or fall was hard or not. They are rings that measure a lifetime. She has spent her years on the planet, moving from the northern chill to the tropical warmth. This is her 19th trip northward. As she travels, she sends a long, single-note humming tone out into the deep sea by pushing air around the spaces in her head. Her calls are louder than a jet engine and are heard by other whales over 500 miles away. Her 400-pound heart is the size of a golf cart. It has never failed to push blood and oxygen to every cell of her enormous body. But today, something is different. Her heart is slowing down. It's wearing out. It's pumping less and less oxygen to her lungs, brain, and other internal organs. This year, she will not make it to the feeding waters in the north. Her vision blurs and darkens, her breathing slows, her awareness fades, her heart quiets, and finally stops. This year, this day, this moment, after 90 years of life, as all living things must do at some point, she dies. It is the end of one story, the story of a whale's life, but it is just the beginning of another story. The death of a whale awakens and ignites a cascade of new life. An entirely new ecosystem will build around this singular whale's passing. Her body will provide shelter and food for millions of creatures for more than 100 years. A whole new world will arise. Scientists call this a whale fall. It starts right away. Gases begin to expand in the whale's body, and it floats up to the surface of the ocean. Bacteria, which have lived harmlessly within the whale her whole life, are no longer being controlled by her immune system, and they grow wildly. They begin breaking down cells and creating more gases. The heat of the sun warms the body, and chemicals leach out into the water, signaling to scavengers that food is available. Sharks and fish zip to the scene and begin to nibble at the part of the whale that is underwater, while seabirds fly in and feast from above. As time passes, gases such as carbon dioxide and methane leak out and scatter into the surrounding air and water. The body is no longer kept afloat, and it starts to sink. For the first few feet, the water is bright and blue and warm. Sunlight pierces the surface and lights up the top layer. The sun can only reach so far, and as the whale body falls through the bright blue layer into the darker, inky colored water, the temperature plummets. The weight of the water is colossal. As the whole whale body sinks, the pressure squashes in and squeezes the air out of the sinuses, lungs, and inner ear. Bubbles escape and rise from the body, twinkling silver in the sunlight just before they pop through the surface. The body keeps falling through quiet stillness, sometimes only inches per hour, sometimes yards, depending on the level of saltiness or the temperature or current in the surrounding water. Glowing shrimp, jellyfish, and other creatures twinkle nearby in the dark. 130-foot long, worm-like siphonophore wiggles and flashes like a bizarre string of holiday lights. A bloody belly comb jelly flickers with 8 rows of glittering rainbow light pathways that rim its bright red body. In the distance, a barrel-eye fish floats by with 2 glowing green globe eyes set in a see-through head. These sparkles of light are called bioluminescence, created within the bodies of creatures when chemical reactions inside cells give off light. A shimmering language is sent out to communicate across the sunless seawater. Green and blue trails flash and streak as the whale sinks past. Days pass, the whale body drops deeper and deeper. The sparkling in the surrounding water is less frequent, as fewer and fewer creatures can survive at these depths. At 3,000 feet below the surface, the whale body slips out of reach of the sun's longest rays. The dark blue of the sea makes an almost imperceptible shift to pure black. For almost a month more, the whale body slides downward through the frigid, pitch-black water. Eventually, it lands softly on the seafloor over 6,000 feet, more than a mile down, kicking up a tiny cloud of what looks like snow. It's called marine snow, but it's actually microscopic bits of dead animals and plants and minuscule skeletons of diatoms, tiny algae that live in the sea. Marine snow drifts down to rest for thousands, even millions of years on the lightless seafloor, undisturbed until now. It's hard to sustain life in this barren place. The temperature of the water hovers around freezing, and the pressure of all the water overhead is crushing. There is no light, and the food is scarce. Most creatures, such as vampire squids, squat lobsters, and eel larvae, survive by eating marine snow. It does not contain a lot of nutrition, but it's enough to keep a few resourceful creatures alive. So when hundreds of thousands of pounds of food falls from above all at once, things change. Generations and generations of over 400 different species of deep sea creatures, from fish to worms to crabs, clams, jellies, eels, and octopuses, will feed, grow, have babies, and thrive on the body of this whale. Other creatures will feed on the animals feeding on the whale. The whale body becomes the foundation for an ecosystem, tangled with food chains and webs, interlocking the lives of thousands of creatures. Scientists look at the timelines of whale fall ecosystems in terms of overlapping phases. The first phase is known as the mobile scavenger phase. In this phase, animals eat the muscle and fat tissue, leaving behind the skeleton. When a carcass lands at the bottom of the sea, it gives off a trail of chemicals that reach across miles of open water. Hungry scavengers will emerge from the darkness almost immediately. Pink eel-like hagfish is first on the scene. It ripples like a ribbon through the water, searching for food. It has picked up the scent of molecules emanating from the whale's body. The hagfish zeroes in, follows the trail to the whale, and slams its head face first into the soft flesh. Hagfish do not have jaws like other fish. Their mouths are round suckers lined with 2 rows of sharp, scaly teeth. It tunnels deep and begins to feed, sucking up nutrients through its mouth and through its slimy pink skin. More and more hagfish descend on the whale. Their feeding sends more food chemicals into the water, alerting more scavengers. The frenzy also invites predator fish that may be looking to make a meal of a hagfish. This, however, is not as easy as it might seem. A fish that tries to take a bite of a hagfish gets a nasty surprise. When the hagfish is harassed, it instantly blasts bucket loads of slime out of the tiny pores on its skin. The gooey mucus cloud clogs the mouth and gills of any would-be predator and sends it off gagging as the hagfish continues to eat, unharmed. Moving like a silent 22-foot-long food-seeking torpedo, a sleeper shark zooms in. This deep sea eating machine is built for finding and gobbling up things that fall to the seafloor. Practically blind, the sleeper shark's small eyes do not see very well in the dark, but the shark's smelling skills more than make up for that. Like the hagfish, it can sense chemicals in the water over a mile away and makes a beeline to a fresh whale fall. It has a powerful bite with rows of razor-sharp teeth, perfect for chomping off huge chunks of meat. Grenadiers, also known as rat-tail fish, arrive soon after the sleeper sharks and strip away the flesh with their knife-like teeth. They are sloppy eaters, spewing out chunks of whale flesh as they chew. These irresistible tidbits scatter the surrounding seafloor and lure even more hungry animals. The first food chains are beginning. After a few weeks pass, the carcass is a busy city. It crawls with squat lobsters that scooch across the surface, pinch off hunks of flesh, and stuff themselves. Millions of sea scuds scamper across the skeleton and pick it clean. Octopuses nestle in the rib cage and devour the soft tissue and cartilage in between bones. Like guests that gorge themselves at an all-you-can-eat buffet, these creatures will doze as they rest between feedings. Even though together these scavengers can eat 80 pounds of whale blubber and muscle every day, it still takes years to finish off the soft flesh of a whale. After the skeleton is picked clean and the bones are exposed, there is still plenty of food to be had by the next group of deep-sea diners. A new phase of life at a whale fall starts. Phase 2 is known as the enrichment opportunist phase. For up to 2 years, a new wave of creatures arrives to take advantage of the leftovers from the original scavengers. Fragments of decomposing flesh and waste material enrich the sediment around the carcass. Crabs, snails, clams, and worms are the opportunists. They discover the remains, plunge themselves into the mud surrounding the skeleton, and feed on the scraps left behind. As days, weeks, and months pass, colonies of clams, snails, and crabs grow, expand, and cover the area around the skeleton. Floating freely through the ocean are countless microscopic worm larvae, carrying a team of bacteria waiting for the right opportunity to grow and flourish. The bacteria help the worms to feed, and the worms give the bacteria a safe place to live. Most of the larvae are eaten up by other sea creatures, but some get lucky. The larva of a bone-eating zombie worm alights on a rib and sends out tiny roots that slowly squeeze their way into the bone. Inside the roots, the bacteria create an acid, which seeps into the whalebone and begins to dissolve it. This frees up fats and other chemicals for the worms and the bacteria to devour and digest. It also creates a space in the bone where the roots wedge in. Eventually, the worm is firmly attached and feeding. This worm has no eyes, stomach, or even a mouth. A feathery red body sprouts up and waves gently in the water, soaking up oxygen and releasing thousands and thousands of eggs loaded with their helpful bacteria. The eggs hatch into larvae, which float and settle on nearby bones, develop, and root in. In time, the skeleton looks as if it has a new coat of glowing pink fur. Each strand is a worm. These small scavengers can spend as long as 10 years harvesting the food locked within the bones of the whale. And those bones, both big and small, begin to crumble away. Years pass. Life on the whale fall is still changing. The flurry of activity is mostly microscopic now. This phase is called the sulfophilic phase. It will last over a century. Drawn into the chemicals released by the worms, blankets of bacteria in vibrant oranges, yellows, reds, and whites cover every inch of the remaining skeleton. They break down the fats inside the cells, use up oxygen, and create sulfur-rich chemicals like hydrogen sulfide. With a rotten egg smell, these chemicals leak into the water and, in turn, advertise a new menu. Hydrogen sulfide is poisonous to many life forms, but to some deep-sea creatures, it's a banquet. Rare species of hungry snails, mussels, and worms, their guts souped up with swarms of their own sulfur-loving bacteria, creep, wriggle, and float in to graze. Resourceful clams bury themselves in surrounding mud. They may look like regular clams at first, but they are very different under the shell. They have no gut. Instead, they contain mostly red, fluffy gills that store specific bacteria inside that allow them to turn sulfur into sugar, which fuels the clam. By now, the whale's body has created one of the biggest ecosystems on the seafloor. Over 150 years have passed since the whale fell to the seafloor. The hard structure of bones still stands. These giant bones offer a place to live and a boost up into the currents near the ocean floor. Being higher in the water allows filter-feeding animals such as sponges and anemones to a better place to screen the water for falling marine snow. This stage is called the reef phase, and it overlaps with the sulfophilic phase. While the large bones reach upward, chemicals such as calcium, nitrates, and phosphates seep from them and mingle with water, but they don't stay in the deep forever. Every spring, cool, dense water rises up toward the ocean surface, carrying nutrients from the deep with it. This year, it contains chemicals from the whale fall, too. When the nutrients rise to the upper layers, where the sun's rays light up and warm the waters, they feed massive blooms of algae and other plankton, which in turn feed krill. Sunlight shimmers down and the water is full of life. Crowds of krill swarm together, a whirl of energy as they dine on the abundant plankton. They are not aware of the huge gaping mouth that looms up from beneath to devour them. A hungry young blue whale surges, scoops, and strains the water through her long baleen, feasting on the krill. She gives her tail fluke a beat and swallows a busload-sized mouthful of tiny krill. Krill that have been fed by the plankton that were fattened on the nutrients gleaned from the remains of a long-gone whale. She carries a calf inside her, which she will give birth to in the wintertime when she returns to warmer southern waters. And in a beautiful circular way, the whales of the past, the present, and the future swim on.